Looking at some CCEA past paper questions here. This one's from June 2018. It's an integration question, mostly a bit of partial fractions, some other stuff in there as well. So find the integral of x cot squared x dx. It's a fairly tough one. So let's look at that at part A. The integral of x cot squared x. A couple of ways to attempt it really. Integrating cot squared x isn't really all that nice. However, integrating cosec squared x is quite straightforward. It just ends up being a minus cot x. So we're going to rearrange this one and try and work out then from there. So this is the same as x cosec squared x minus 1. And again, the reason I'm doing this is that cosec squared x is easy to integrate, cot squared x isn't. So that means we have the integral of x cosec squared x minus x dx. This is now going to be integration by parts, and we're going to just do this wee bit separately then at the end, so hopefully that won't confuse. But if I take this part here and I let my u equal x and my dv by dx equal cosec squared x, I get du by dx, which is 1, and then v is minus cot x. That means we have uv, which is minus x cot x minus the integral of v du by dx. So do you see what we have here then? Let me see, so the minus takes from the minus here, so this turns into a plus of a cot x dx. And then here, whatever way you want to write this, but I'm happy to integrate this. No, I just write it here, so it's what is it, a minus the integral of x dx. So we get minus x cot x. How do you integrate cot x? So cot x is cos over sine, and if you differentiate the bottom, you get the top. So it's just an ln sine function. Again, that would be in your formula booklet. So we're pretty much here. So we get minus x cot x plus ln sine x, and then integrating this gives us minus a half x squared, and remember at your end then your plus c. Part B, write in partial fractions 2 over x upon 2x minus 1. 2x 2x minus 1, a over x plus b over 2x minus 1. That's a upon 2x minus 1 plus b upon x all over x 2x minus 1. I can now equate my two top lines. So 2 equals a upon 2x minus 1 plus b upon x. If I let x equal 0, that means I get 2 equals minus a. So that gives me, obviously, a is minus 2. If I let x equal to a half, I get 2 equals to a half b. Again, I hope you're okay with that. That makes this bit disappear. So of course it gives me a value of b equals 4. So that means my question becomes, just trying to fit it all in here, hopefully you can see, 2 over x upon 2x minus 1 equals, my a is minus 2, so it's minus 2 over x plus 4 upon 2x minus 1. Okay, Part 2 then, so I assume we're going to be using this somewhere here to try and solve this. Use the substitution x equals u squared where u is positive to show that this equals this, where a and b are integers to be found. So I'm going to try and do it down this side of the page. So we are doing the integral between 9 and 1 over x upon 2 root x minus 1, and we're going to have x equals u squared. Quite often it's u equals something, but that's okay. So we have then dx by du, which is then going to be r2u. So let's see what we can do here. So I would rewrite this. Let's just do a wee line down here, try and keep these very separate. Integral between 9 and 1 of 1 over u squared. What are we going to have here? 2 upon, that's the square root of x. The square root of x is of course just u. So it's going to be 2u minus 1. And then it's going to be dx by du. So that's going to be times by 2u du. So let's try and tidy this up a bit. The integral between 9 and 1, that u is going to cancel out with the u squared there, so that is going to go with that, and we end up then with a 2 on the top, all over u upon 2u minus 1 du. I've done something a bit weird here. I should really kind of get rid of these and redo my limits. F of x is u squared, so with 9, if I sub in 9, then that gives me u is 3, and if I sub in then x is 1, then I have u equals 1. So my limits then will change over 3 and 1. I'll do that then from the next line. Also, do we recognize this? This is the question we did only with a x over here, so that means I can rewrite this here as this. So it means I can separate this bit out. So it's really the integral between 3 and 1, sorry you can't see that, of minus 2 over u plus 4 over 2u minus 1 du. So we're getting there. We can now integrate. So minus 2 over u is going to give you minus 2 ln u. This here we need to take out just the 2 bit. If you differentiate the bottom line, you're going to get 2, but we're on 4, so we take out the 2 there, so it's 2 ln 2u minus 1, and those then are between 3 and 1. Minus 2 ln 3 minus 2 ln 6, take away 1, so it's ln 5. Subbing in 1, minus 2 ln 1 minus 2 ln 2 times 1 gives me 2, take away 1 is 1. So that all just disappears because ln 1 is 0. So we just have this then. So we have, let me see, minus 2 ln 3. I've made a mistake somewhere. What's going on? Oh yeah, let's be a plus. Sorry about that. Plus 2 ln 5. Let's see, we'll rewrite it just so people can see what's going on. So it's 2 upon ln 5, take away ln 3. So take a wee second, make sure you understand that. I've rearranged, taking those around the other way around, and then I use my laws of logs here. So I have 2 ln 5 over 3, and that's us finished up. So a fair bit going on there in that question.